Today in Capetri's Corner, we're going to look at the functions involving square roots. In this lesson, we're going to graph a few functions and we're going to identify the domain and range. The first one says y is equal to 2 times the square root of x. So when graphing this, I'm going to make a table, but the first thing I have to do is I have to identify the lowest value that x could be. Since x is under the square root sign, and I know that it has to be positive, I know that x has to be greater than or equal to 0. Now, when I do my table, I'm going to start with this value, the lowest that it has to be. So I'm going to make x is equal to 0. When x is 0, that makes 2 times the square root of 0, also 0. Now, I can use any values as long as they're above 0. I'm going to use a couple perfect squares just to make it a little easier for me to graph. So if I use 1, 2 times the square root of 1 is 2. If I use 4, 2 times the square root of 4, well, the square root of 4 is 2, so 2 times 2 gives me 4. And my last value will be 9. 2 times the square root of 9, so the square root of 9 is 3, so 2 times 3 is 6. Okay, so I'll plot them, 0, 0. Then I have 1, 2, and then I have 4, 4 is there. And then 9, 5, 6, 7, 8, 9, and up 6 is here. Now I have to be careful when I connect it. We're not making a line, and remember we do have a starting point. The numbers can get bigger and bigger, but they cannot go below 0 because the radicand is x, and I know the radicand can't be a negative number. So at 0, 0, that's where I started. I'm going to connect it, and there's only going to be an arrow on one end, meaning that the x values can continue in that direction, but they cannot be less than 0. My domain is my x values, which remember we cannot have less than 0. So I'm going to say x is greater than or equal to 0. My range, I'm going to look at my table. I start at 0 and my numbers just get greater, so they're never going to go below 0. And you also can tell that from my graph. My y is my axis goes up and down, so I notice that I'm starting at 0 and they're getting higher. So y is also greater than or equal to 0 for my range. The next function we're going to graph is y is equal to the square root of x plus 1. Now again, underneath the radical sign, our radicand is x, so I know that x has to be greater than or equal to 0. I know I can't have a negative number, so my lowest value x can be is 0. So when x is 0, I'm going to take the square root of 0, which is 0, plus 1, so y is 1. Now let's take a number that's not a perfect square just to see what we do. So I have the square root of 2 plus 1 when I use my calculator is just about 2.4, so we're going to estimate that when we graph. Now I'll take a perfect square just to make it a little easier. The square root of 4 is 2. 2 plus 1 gives me 3. And then I'll use 9. The square root of 9 is 3. 3 plus 1 gives me 4. Now to save some time, I plotted my points. So again, 0, 1 is my lowest value I can have. So that's my starting point. Then I have an arrow to the right because my x values can continue to get higher. So my domain, remember, it's my lowest value x can be. That's where I start, which we decided was 0. So x is going to be greater than or equal to 0. My range, unlike the last problem, it's not going to be 0, it's going to be 1, but again, my values are getting higher, so the range is y is greater than or equal to 1. In the next problem, I have y is equal to negative times the square root of x minus 2, so I know my radicand x minus 2 has to be greater than or equal to 0, because I know I can't have a negative number underneath my radical sign, so I'm going to add 2 to both sides, and I have x is greater than or equal to 2, so it's going to help me. That's going to be my starting point for x. When that's my x value, I get the square root of 2 minus 2, which is 0, so my y value is 0. Now I'm going to pick a couple more values for x. I know that 2 is the lowest value I can use, so I'm going to go a little higher. I have 4. The square root of 4 minus 2 gives me the square root of 2, times negative 1 gives me about negative 1.4. I'll pick 6. So I have the square root of 6 minus 2, which is the square root of 4. Square root of 4 is 2. 2 times that negative 1 up front, I can't forget about that, gives me negative 2. And the last value I'll pick is 8. When x is 8, I get the square root of 8 minus 2, which is 6. Negative 1 times the square root of 6 gives me negative 2.4. I've plotted the points, so notice that 2, 0 is my starting point, and I can continue going with arrows on the right there because my x values can keep going. When I do my domain, my lowest value there is 2, and again the numbers are getting higher, so I'm going to say x can be greater than or equal to 2. My range this time is negative, so my lowest value is 0, and my numbers are getting lower, so my range this time is y is less than or equal to 0. Now we have y is equal to the square root of x plus 1 minus 3. So again, my radicand is x plus 1, so I know that has to be greater than or equal to 0. Bring the 1 to the other side, so I have x must be greater than or equal to negative 1. So it's going to be my starting point. I substitute it into my function, so I have the square root of negative 1 plus 1, which is 0, minus 3, so my y value will be negative 3. Let's use a different value. Now again, it doesn't matter which values I use as long as they're greater than negative 1. So let's use 0. So if the square root of 0 plus 1 is 1, the square root of 1 minus 3 gives me negative 2. And if I use a different value, if I have 2 plus 1, the square root of 3 minus 3, that'll give me a negative 1.3. And again, one more, I have 3. 3 plus 1 is 4, so the square root of 4 is 2, minus 3 gives me negative 1. So after I plot my points, I know I'm going to start with my first point there, negative 1, negative 3. And I want to go to the right, arrow to the right, because x values can be greater than the numbers I've used, but they cannot be less than negative 1. So my domain is going to be x is greater than or equal to negative 1, because I start at negative 1 and the values are getting higher. And y, my lowest value is negative 3. And again, my values are getting higher, so I have y is greater than or equal to negative 3.